slow week after the exam and everything and whatnot. Um, was it slow for you last week?
What do you mean by slow?
And maybe slower speed in class, or maybe in class we're doing something else other than discussing new stuff. I don't know. Uh, they just feel a bit slow, lah. Or if it feels normal, then I also understand.
Feels slow.
Okay, okay. Hmm. Okay, that's for AMAT, lah. All right. Uh, Last time I told you something like this, right? AMAT, your most challenging subject, right? You are the last student that haven't studied that subject before class, lah, right? So I was advising you. I think we gotta start doing that. Mm, did I tell you what happened to my other students when they start studying before class?
No.
I'll use the time to tell you a little bit of that. Okay. One of them, I guess one of them suddenly scored very well. It almost feels like a sudden thing. It almost feels like that. It almost feels like that's the only problem she had previously, right? Um, she just scored from fail to very, very satisfying for her. It's not that she doesn't practice more, but because she understands more of the class, she is able to practice better. Previously, she also practiced, but the practice doesn't give her, the fruit she wants. It's just not satisfying at all, considering all the hard work she did.
Okay.
By that simple change of trying to prepare for class, way ahead, not near exam, she just finds her study to be more fruitful. If that's the kind of thing you want, then generally this happens to everybody. Yeah. The case just now I mentioned is quite how do I say it? Quite extreme. It's really from fail to suddenly very good, which is good for them. Now, what about other students? Their students experience how do I say it? Something like this. The lowest, let's just call that the highest possible improvement. Okay, from fail to very good. Okay, what's the lowest possible improvement that my student experience? Okay, it goes something like this. After exam, the exam result not very happy, right? But first of all, they pass. Okay, this is after 2 or 3 months of doing this, right? Okay, the mistakes in the exam are not because they're confused. Most of them, they actually know how to do it already, even if it feels a bit more difficult. So the exam difficulty is not so much of a problem, but they make silly mistakes, careless mistake. Actually, they make small mistakes instead of big mistakes. Okay, if you make enough small mistakes, you still end up with a not so nice exam result. I hope that makes sense.
Yeah.
But what I'm saying is that the quality of their exam actually improved. They are still disappointed, but they are no longer clueless, is what I'm trying to say.
Okay.
Okay. In a very extreme case, the most difficult school, right? I'm talking about not AMAT, but I'm talking about physics, School of Science and Technology. I don't know whether you've heard of SST. Right? SST is known for giving their student just stupid difficult question, just stupid difficult, all the time. Right? That guy almost passed. So it's not a pass, almost passed. It's very sad, right? Very sad. But that sounds very bad until you compare his previous result. His previous result is even worse. And this exam, this newest exam, was the harder topic compared to the classes. So objectively, he should feel like he improved. It's just that he doesn't feel very good because it's such a difficult questions on paper, and he almost passed. He almost in that case. There are a few cases where they don't improve at all. So they are very easy to understand. One case is because the class is just very bad. That student simply cannot rely on the school class. Maybe the teacher not very good, maybe the teacher absent, maybe the teacher cannot control the class is not good. The whole point of studying before a class so that the class benefits more. But if the class wasn't good in the first place, that might not happen. Now, if that is your case, you tell me immediately. When I asked you last time, how's your AMAT class? I have an impression that you think your AMAT class is good. I have an impression that you think you seem to be the problem, not the class. If that suddenly change, you must tell me. The strategy no longer works in that case. You understand?
Yeah.
The second example, also very easy to understand why there is no improvement. It is because the student is very lazy and doesn't sleep well. Very lazy means he only practice before exam. Improvement in class doesn't matter. He's not interested in doing his homework or something like that. But he will study before exam. But the whole point of the strategy is to prepare you way long before. Let's not pile the stress near exam. But that's what you did. So there is no point in discussing something before class discusses. No point at all for him. He likes it, but there is no point. Something like that. Now, you also don't seem to be that type. Okay? If you suddenly change, I won't scold you, but you must tell me, you must tell me, I'm not interested in preparing my most difficult subject long before exam. I'm more interested in preparing it just the minimum amount of effort. If that is what you want, you must tell me. Then we discuss a totally different strategy.
Okay.
I'm quite open that way, if you understand what. But you gotta tell me you are what and what's your goal and what's your thing. Okay, Abigail?
Okay.
Now, if you don't have those two extreme problems, the class so bad or, study habits so bad, if you're not those two, then the promise is you will experience some sort of encouraging improvement. That is the promise, plain and simple, right? If you give it some time, the promise grows, the promise becomes, you suddenly are able to enjoy the subject. Okay? You suddenly see your effort bearing slightly more fruit that you will expect. Okay? You suddenly see that you can understand this subject. Those kind of good stuff. Okay? Right? That is if we try to do it consistently. Okay? Now that is true for most of my students, and that's why right? All right?
Yeah.
Now, so we can and we should discuss your homework if you have. If you have a holiday homework, it's best to do it early than later. Do you want to start with your homework today, or shall we go discuss your topic in advance right now?
Let me check.
Mm-hmm.
I like to discuss my homework.
Discuss your homework and tell me what kind of homework is it?
In math, it's about graph. It's
This is the EMAT one.
yeah. The teacher hasn't given me my AMAT homework yet. I can't do anything about that.
So there will be a AM homework something like that.
Yeah.
Okay, understand. Okay, good. Let's limit our time to maybe 6:45. Is it? Do you think it's enough for the homework? All right, 6:45. Put your questions in. We'll discuss, and then we'll study in advance. Sorry, are you using a different Jamboard?
Yeah, I'm using the email.
Right. Okay. So, Math part 3, right?
No, just email.
Just email. Yeah. Okay. Nothing yet, yeah? Okay, I believe I'm in. Okay, a bit of physics, so this is good. All right. This chapter will benefit you and physics. So, anything else?
Yeah, one more. And that's it.
Okay. Now, I've read the question. What is your problem? Abigail, what is your problem? Oh,
I don't know how to start.
this is from physics, yeah? This is from physics. So, I want you to remember the concept. This is speed and time. I teach you how the question will ask you. If you see a speed and time diagram, what do you expect the question to ask you? Tell me.
Distance.
That's one. Two, there are two things. If you cannot remember, look at 1A. That's very obvious.
time.
Acceleration, or rather, in this case, he actually give you acceleration, and then they ask you for time, right? Which is, how do I say it? That's not very different, right? Either giving you acceleration, asking you for time, or asking you for acceleration given time. Same thing, same thing. What do I mean by same thing? They are not very interested in asking you the speed. This is not a graph reading question. Never is, never interested in that. Make sense?
Yes.
Now, you told me that you do not know how to start. Do you remember that this is what you have learned in physics?
Not really.
All right. Be careful, Abigail. It might be that your study doesn't somehow your study habit doesn't kind of I don't know, help you understand deep enough, maybe, and then it causes you to have to repeat things. Like, it can be a minor hassle, right? Tuition will help you, definitely, but that was never the goal for my students. At least I don't see you as that kind of student. I don't see you as that kind of student who needs a lot of repetition. Why? Because I think you're rather smart. That's what I think. That's what I think. Right? So let me try to explain it. Now, one thing a good student do, Abigail, if you want to be a good student, you ask many questions. If you're not, don't be too easy to be satisfied. Yeah, to be satisfied with your understanding. Try to ask questions, even though it might feel like it's unnecessary. But this is tuition, right? You can ask me anything. Right? This is not a class. You just stay still one. Okay? It's not a replacement for your class. I speak, you absorb. Maybe that's why your understanding is not very deep. Who knows? Yeah. Now, I tell you the expectation already. Remember it. If this is a speed time graph, he will not be interested in asking you speed. He will be interested in asking you distance and acceleration, or give you acceleration and ask you for time. Same thing lah. Okay?
Never
Now,
mind.
mm-hmm.
I got the
Then,
first question.
good. So tell me, what's acceleration in the speed graph?
This part.
What do you mean by this one? So tell me the formal name for that. The acceleration in the speed graph is the what?
Huh?
I was hoping to say that is the gradient.
Oh.
I think that you say is the gradient. No, but is that what you did?
No.
Then how did you get p equals to 15? You show me. Okay, looking good so far. Yeah, like that. Then what happened? Now tell me, if there is no answer key, if p is not equals to 50, can you do this or not?
I'm not sure.
You're very easily satisfied, and you're not a good student if you just stop here. Now, your choice, this tuition always involves your choice. Your choice. You want to understand deeper, I will give you. If you don't ask for it, I won't give you. Assume that you're satisfied with your current level of understanding.
Explain a bit, I guess.
All right then. Now, I mentioned something about gradient. Now, I really mean the math gradient. Let's just treat this as a math question or physics question. You do understand what's gradient, right? Just to
Yes.
confirm first. Okay, right. So tell me, what is gradient to you? Anything you want, whatever, formal, informal definition, you tell me.
Rise over run.
Okay, let's say it's rise over run. And I claim that the acceleration has something to do with the gradient. Now, let's see first. Let's see first. Now, I'll explain you in two ways. So, for some reason, you end up doing a rise. Correct or not?
Yeah.
And you are looking for a run. Wouldn't you say that?
Yes.
So, I claim rise over run, which is the gradient m, right? Rise over run is going to be the acceleration. That's my claim. That's my claim. So I put the rise here, which you found nicely, and the upper acceleration is 0.8, and you're supposed to find the run. Okay, with this understanding, now obviously your method is correct, right? Obviously your method is correct. I'm just asking, if I use rise over run, will it end up being the same, you think?
No.
Try finding the run using this. Let me see how you do it.
Well, my acceleration is correct.
Of course, because it's given, right? It's given as 0.8, so I'm not surprised there. Like, you cannot use 50, please. Please don't use 50. Now, this one is, I have to explain. If they say show that p equals to 50, you cannot use 50 in any way, form, or shape. You cannot. You must arrive at 50 at the end. Do you understand this? Because I don't want you to consider this as a rule. Do you understand
Yes.
this one?
Yeah.
Then don't break it. Don't break it. Right? If you break it, that means you don't understand the rule. Then I have to explain. This happens a lot of time. Go, find your x. Okay, I'm going to stop you there. Right? I'll stop you there, yeah? Now, this is your math problem. My job is to tell you, right? See whether you want to change or not, right? This should bother you a lot. If this doesn't bother you, big trouble ahead, right? Now, the most important technique in math is the order, nothing else. Whatever you do to the left, you do to the right. This is correct, and this is correct. And then suddenly, these two things is wrong. It's very scary for me. Now, you want x, right? You want x. The x is at the bottom. Now, think in terms of door. Whatever you do to the left, you do to the right. How do you make the x go to the top? Abigail, I confirm your math again from secondary 1, secondary 2. Did your teacher teach you, hey, move this around? Move the x around. That's how you do algebra. Is that how they do?
No. I don't remember.
Then how? Then learn math from me, Abigail.
Okay.
This x is at the bottom. You want the x to be something like this. X equals to something, right? Let me confirm that this is what your goal is. Your goal looks like that, no? X equals to something, okay?
Yes.
Your x is in the bottom. That's a problem because your goal is the x is on the top. Now, is there any way for you to get the x from the bottom to the top besides moving things or magically moving things? It feels to me that you are really doing something. You know what? Never mind. I'll just show you first. You know, never mind. Okay, my first door. Agree with this. First door is 2 times x on the right-hand side and times x on the left-hand side. As a result, please tell me what happened to the left-hand side.
It becomes 40.
Very good. And you're correct. Absolutely correct. And then the right-hand side will become. Okay, some people do this on paper. Some people do this in your mind. I take it that you kind of do this in your mind. So as long as you agree, I'm okay with that. What's the next order to do? Let's look at it this way. You want x 0.8 is troublesome for you. You hate the 0.8. Can I say it that way?
Yeah.
So how do you get rid of the 0.8? I'll give you 4 options: plus, minus, times, and divide.
Divide.
All right. Divide by what? Just checking.
Divide by 8.0.
What do you mean by 8.0? Think carefully, Abigail. Just now you say 8.0. Are you sure?
Yeah. Like,
Read for me this. What is it? Yeah. Didn't you realize you say 8.0 instead of 0.8? Did you realize that?
no.
All right. But I can see that you meant the right thing. Let's focus on that right now. Okay. So you are correct to say divide by 0. I like it a lot. I like it a lot. As a result, you have seen what is going on here. So you should be doing this. 40 divided by 0.8 equals to x, right?
Okay.
Now, you insist twice. 40 times 0.8 is 50. 40 times 0.8 is 50. I feel that here, your logic is not working. How can 40 times something smaller than 1 become 50? And yet you didn't realize. But here, I feel your logic is working. Go and test first. 40 divided by 0.8, is it really 50?
Yeah.
Good. Now, here's your logic not working. Cannot be 1. 40 times something smaller than 1 becomes 50.
Yeah.
Right?
I can see it.
Good for you. No, really good for you. Really good. Okay, now, yeah. So the rise overrun seems to be working. You seem to need something more than your current method, right? Current method. I'll give you one more thing. Hopefully, it will increase your understanding. Hopefully. Okay, let's check the unit. What is the unit of the rise?
Meters per second.
I totally agree with you. What's the unit of the run?
Second.
Acceleration has its own unit. What is it?
Meters per second square.
You are absolutely correct. What is meter over second, so to speak? Meters over second. What is that?
What do you mean?
Look, the rise is meter per second, which is 40 meter per second. The 40 is meter per second, I'll put it there. Okay. put it here. The 40 is 40 meter per second, and then divided by the run. The run is 0. I'm sorry. In this case, it's not the run. I'm sorry. In this
Just
case,
me.
it's not the run. I'm sorry. Because then have to talk the acceleration. No, never mind. So the run is in this case 50 seconds, right? 50 seconds, right? 40 meter per second divided by 50 seconds. Of course, the answer is 0.8. I agree. But is the unit actually meter per second square? Meter per second divided by second. Does it become meter per second?
No.
Then what does it become? Meter per second divided by second. What do you think? What should
Just
it?
meters.
Just meter. All right. Then let's talk about it, because this is something you totally cannot ignore, right? Cannot. Okay, look at divided by second. Okay. According to primary school, our important foundation is 1/2. Would that be okay?
Okay.
Then what does this become? Is it becoming meter, Justin?
No.
So what is it?
Meter per second square.
Right. Now you're the one that say meter instead of meter per second square, but upon further checking, it is meter per second square. The unit matches. I'm telling you that this is very important. I'm telling you, this is not something that you ignore. I noticed that teacher never teach it. I noticed that a lot. This should save a lot of mistakes in exam. Meter per
Okay.
second divided by second is meter per second. So that's where you know, hey, I'm using the right thing. This formula is not bogus. The formula kind of matches the unit. Hey, okay, I get it. I like it. Something like that. Okay. Now, in the distance later, you will see something different. I guarantee you, you will see something different. You will see meter per second times second instead of divided by second. I guarantee you that. Why? Very simple. What is meter per second times second?
Meter per second cube.
You're not making any sense, isn't it? Think carefully, yeah? This is important for your math, in physics. Meter per second times second is meter per second cube. Are you sure?
It's meter per second square.
What's going on here? What's going on? This one cannot let go. This one cannot let go. This is very dangerous. Okay. So one more time, meter per second divided by second becomes meter per second square, right? Don't tell yourself meter per second times second becomes meter per second square also. Does that even make sense?
Use meters.
So which one is it, Abigail? Which one is it? Are you sure it's meter? Are you sure?
Yes.
Why is it meter, not meter per second square? You tell yourself. Okay, you're doing something. Right? All right. Okay, totally understand you. Your primary skills are there. Okay, very important. Good. Now, this is my promise. Yeah? This is my promise. In acceleration, you see this because it makes sense. In distance, you see this because it makes sense. If you don't see this, kind of something wrong, that's a good sign that something's wrong with your work. Yeah? So now, do you understand question B? It's not that easy, I would say. It's not that easy. It's like medium kind of thing. Do you understand what's going on?
They're asking for like this straight line.
I totally agree. Okay. To help you, no problem. To help you, I'll call this something else. Can you give yourself an alphabet?
Why?
Okay, let's put it as Y. Let's agree he's asking you to find PY, correct? Something like that.
Okay.
Okay. Now you're saying that you do not know something. What is it that you do not know?
I don't know how to find like this specific part.
Totally agree with you. Now, here's a few good news. Hopefully, it is good news, right? This is EMAT, and this is now suddenly a shape question. I don't know, you call it geometry. I don't know, you call it, shape, triangles, squares, rectangles. Not the hardest topic. If you have a problem, that's why you have a problem. Or you hate shapes. Why do I say shapes? Because if acceleration is the gradient, I promise you, right? Acceleration is the gradient. Distance is, of course, not gradient. Your teacher will tell you something about the distance one. Distance is the what of the graph. No idea?
The distance is this line.
No. If you say that line, I think that doesn't work because it's a speed graph. Does that make sense? You cannot read distance directly from a speed graph. The same way, you cannot read acceleration from a speed graph, and yet they incessantly insist that you do that. In fact, that's the only thing they ask you to do. I'm going to give you a speed graph, and they test you. Give me acceleration. Give me distance, or even worse, I give you distance. Even worse, actually. Come on, what is it? In the speed graph, the acceleration is the gradient, kind of hidden. In speed graph, the distance is also hidden. Hidden where? Do you know now? It's not in the graph directly. You cannot demand that of the graph. Cannot. Doesn't work that way. The speed graph.
It's the speed multiplied by the time.
You are not wrong, but it feels a little bit, it needs to be a bit more precise. It will be the area of the graph.
Oh, okay.
The area of the graph. And if you forget that, for now, please remember it affects your physics and your emath. Two subjects. The area. The area will later on cause you to do this, I guarantee you. So it kind of makes sense. For now, it kind of makes sense. Okay. Now, tell me what the question means. The total distance traveled during the 180 second. The 180 second is here. Nothing special. Is 5750 meter. Now tell me, what is 5750 in this graph then? What is it?
Area
Of what?
the graph.
Everything lah. Just checking. Everything lah. Everything. Okay. Now with that in mind, can you now do this question? Making a new page for you. Yeah, it's very crowded. Go to the next page.
No.
Refuse to do that. Refuse to do that. You're not gonna wait for me, yeah. So now the area of this shape, you no longer see this question as a speed time. No. It's really just area. You tell me, okay, distance is area. So see this as the area. No? The area of this shape is 5750. Very difficult to see. You don't see any square. Area is supposed to be square. It's very annoying. It's not so nice to the brain. I agree with you. But the area is 5750. Still like that one. Okay. Now, what can you do with this area? Right? For example, this area, maybe you want to divide it to something more manageable. It's always a good strategy. Would you like to do that?
Okay.
All right. Then how do you divide it? That's up to you. You can put as a y. Okay, you can divide that. Okay, that looks nice. Okay, good. Cool. Okay. Nothing else that you can do? Nothing else? Maybe try using the answer of the first question. Usually that kind of helps. The second one, usually, worth a try. Maybe you can do something about it. All right, now that's 50, great. Is there anything else you can do regarding area, right? We are still talking about area here. Anything?
We can find the area of this part.
Go ahead, go ahead, go ahead. Go ahead, go ahead. You do your, this is a math class, you do a math. So what's the area there?
Uh,
Yeah. Yeah, sure, it's 130, which is great. Anything else that you can do?
no, I'm stuck.
Regarding the area. Okay. Totally agree that that's 130. I think that might be useful. Yeah, I totally agree with that. That's the height is, which is 45. I like that a lot. Sure. There are a few ways to do this, but I'm not seeing you utilize the Y. I'm not seeing you utilize the Y in the sense that because you want to find the Y, but if you're not using the Y, how can you find it? You get mental barrier, so to speak. Cannot find it unless you use it. Use it.
I don't know how to implement the why.
Use it. I really mean it. Like use it. Trying my best to not give you a hint here. Can't you use it somehow? Oh, okay, all right, okay. Half times, all right. Mm-hmm. Times 45, okay.
Wow.
Abigail, just to confirm, are you stuck here? Somehow? Sorry.
Yes.
Okay, now you tell me what you think. What you think is very important. It's not what I think which is important. Now, Tell me, what is this? What is this? What is half times this times that? You tell me. According to you, lah. What are you thinking? What are you trying to achieve? Tell me. Abigail, you're thinking about something. You gotta tell me that. Don't worry if it's right or wrong. I'm not asking you the next line. I'm asking you the first line. What were you thinking when you're writing this? Like, what does it mean to you? I didn't know. Why do you do half times this time that? What's the logic behind it? Something like that.
That's the area, right? Like the
area of this whole thing. Okay, again, tell me, why is this half? What kind of area are you thinking? For example, an area of a rectangle doesn't have half, so you must be thinking about something else. Tell me what area is this?
Trapezoid.
You're thinking about trapezoid. Okay, now I understand. So just to confirm, right? I'm going to draw a trapezoid for you, right? Something like that. Okay. Now, I understand that the height of the trapezoid is 45. I agree. And I noticed that the trapezoid formula has a half. So I at least understand this and understand that, if that's what you mean. I don't understand this part. Now, you tell me what this part is for you. At least I understand what's going on. Okay, great. Okay. Okay, that's 50 plus y. And then, okay, sure. But what's the 130? I see what you mean. You're only focusing on this trapezoid. So let me cancel this part, correct? You're only focusing on that part. Am I correct?
Yes.
Okay, I like it a lot. So I understand the 130. I totally like the 130. This one is wrong logically or visually, I don't know. You think again about this. Abigail, your trapezium thinking I like. I think that's correct. Your mistake is not that. Your mistake is this. Think again. Yeah, again, think. That is a mistake. However, the trapezium is correct thinking. Just execute wrongly. Think again. You gotta develop the ability to see your own mistake, because I already revealed to you. It's a bit worrisome if you cannot. Okay. You're saying that now it's a y. Let me confirm. Correct? $50 plus y is wrong. Now the second answer is y. Y is also still wrong. It's better though. It's still better. It's still better. I like it, but y minus 50. Y minus 50, I agree with you now. You okay or not?
Yeah.
Okay. You correct yourself after I tell you that you have a mistake. That's an improvement. Really. Now, change what you're doing, I suppose.
What?
Change what you're doing, Abigail. Wait, shouldn't have the need to tell you, right? That means you need to change something here, right?
Yeah.
Correct. All right, so do that. Okay, looking good to me. All right. Now, I agree that this is the area of what you're talking about. Okay. Now, just to check, you are stuck because this is 5750 or it is not 5750?
That is not 5750.
I like your thinking. That is correct. I agree with you. Can you find what it is then? If it is not 5750, possible or not? Possible or not? Maybe it's possible because you haven't utilized your 5750. You utilize your Y. I like it a lot. You utilize your EMAC trapezium. I like it. Utilize the 5750 somehow.
I don't know how to utilize it.
No, I won't accept that. You make the decision to discount this one. I like that decision. Tell me why you discount this guy.
Because it's like
Tell me the reason.
it starts from like 5 and up 0.
It's a weird shape. Okay, I agree with you, Abigail. That's a good reason to discount. Okay, totally I like that. And you're right, if you include that, you cannot do trapezium. Totally agree with you again. I like your thinking. But because of that discount, we cannot use 5750, correct? That's the reason why. You have your good reason, but you also have a consequence. We cannot use the 5750. So far, so good?
Yeah.
Can't you do anything about that weird shape independently? Okay, now I'm gonna focus your mind on this weird shape. You keep saying that it's weird, so you discount it. I'm okay with that, but come on, can't you do something about it? About this weird shape so that you can still use the 5750? Sure, okay. There's 1,000 there, okay. Okay.
So 5750.
Okay, I can follow so far, sure.
Which is like the area for this part.
No, you're wrong. Not entirely wrong, though. I actually like your Sun 1000. But you need to think a bit more detail. I'm a bit confused right now, actually. So tell me, what's the 1,000 here? How come you don't see it? What is 1,000? Which area is that? Hey, come on, man. Abigail, why do you use half times 50 times 40? That is a nice area. I like it a lot. But come on, which area is that? Okay, great. Yeah, okay. Yeah, okay. Much better. On one hand, you are good, Abigail. Your thinking is clear. On the other hand, your thinking becomes very blurry from time to time. Okay, now I like it better. Yeah, this is nicer. Kind of expect you to spot this yourself next time, yeah? Next time. Okay, nice, nice, good. Now do your algebra. Right? You can move to the next page if you want. Yeah, that's up to you. Abigail, think carefully, please. Think carefully what you're doing here. Okay, you copied correctly. Yeah, I expect you to now see your own mistake if there is like. Okay. Maybe I misread you. Maybe. Abigail, I'm gonna stop you here right now. Okay? Don't erase anything. Tell me you're thinking about times 90. How did that happen?
Um,
Do not erase anything. Just tell me your thinking.
I assume that the multiply sign is like the equal thing.
Now, I take it that you feel that it is not correct, yeah? I take it, can I take it that way?
Okay.
Wait, sorry. Now, I really mean it. If you don't feel that there is a mistake, if you feel there's a mistake because only I say, yeah, that's a problem and I cannot force it upon you. I don't want to force it upon you that I think you're wrong, so you follow. That's not the right way to learn. If you don't feel that this is wrong, I will help you see that this is wrong. It's very dangerous to do otherwise. Now, do you feel or see that this is wrong? If not, tell me.
Yes, it is wrong.
Okay. Then don't erase it. Don't erase it. Now I'm gonna repeat my point. It's good that you can see that something is wrong. Believe me, that's a very important skill. If you know that something is wrong, you have a very good chance to see what is right. If you do not know that this is wrong, you don't stand a chance to see what is right. You can only follow. Follow not good one. In math, follow not good. Now, let's go to the first line again. You please notice this is an equation. Therefore, I keep saying, what is the most important technique in an algebra, equation algebra? What is it? Good. Use your door instead of what you are trying to do. You are trying to focus on the one side of the equation. That is usually not the most fruitful technique. It's better for you to focus on door first. Any opportunity of door should be taken almost immediately. Plus, minus, times, divide. Come on. Which one? It's quite obvious that one guy is very fruitful here. Plus, minus, times, divide. Yeah, this is the part that you have to see yourself. I cannot keep telling you. Plus or minus or times or divide will be very nice here. Make your life easy, Nice.
Multiply.
By what? Tell me first.
2.
All right, because you hate the 2. Now, I'll give you a new perspective. Of course, the 2 must be settled. Of course. But I'll give you a new perspective. What you want is y to be like that. Correct? That's what you want. You want y to be alone. Correct?
Yes.
You want y to be alone. If you want y to be alone, getting rid of the 2 is a good start. I like it. Why don't you, however, get rid of 45 first? I challenge you. That's actually slightly better for your mind, I believe. Is there any way to get rid of 45 and plus minus times divide? Now you're focusing on the one. You're not doing a dollar. You're not doing a dollar. No. Stop. Your dollar ability is low, and that kind of drops you from an easy exam, I suppose. Right. One more time. This is times 45. So happens this is 4,500. I kind of feel that that's not a coincidence that I kind of feel. What can you do to make times 45 disappear? It's so easy. Dollar plus minus times divide.
Divide
Yeah, divide by what?
45.
And if you divide 45 on the right, you divide 45 on the left. Is it really a hassle? Just checking. If you don't find it to be too big of a hassle, please try it and see whether you like it or not. Let's see. Okay. Looks like your mental calculation is good. Okay. Okay. Now let me ask you, is this something that you like personally?
Yes.
Now you can do your times 2 if you want. Not before this. I believe the divide 45 is better personally. Like I feel it's better first. Do your times 2 if you want. Okay, that seems to be useful right now. If you want to do something else, that's also fine. So saying like, right? So good. Hey, we solve for y. Yeah. Great. Good job. Not the easiest question. But is this the answer? Is this what we're supposed to give?
Yes.
Check the question one. You better check the question one more time. I like the 120. I like it a lot. But are you sure this is the final answer?
No.
Okay, then what is the final answer? Are you continuing as well? Are you continuing also? You are, yeah, you're doing that. Abigail, tell me your thinking. Why do you divide by 45? I understand that that's the height lah, but why do you do that? Is that your final answer, sir?
No.
Okay, okay. What are you supposed to find visually, please? Visually, you identify to yourself. I'm supposed to find this guy. I believe you were correct just now. What was it that you're supposed to find visually?
To find seconds.
No, that's fine. No, that's fine. That's fine. And by the way, 120 is not meter. It's 120 is second, by the way. It's Y. Y is in the time axis, so to speak, and 120 is therefore second. You're already at second. Do you understand?
Oh, okay.
Then, is this your final answer?
Yeah.
And you are still wrong. Now go back to the picture in I don't know in the previous stage. 120 is great, okay? 120 second is great, by the way. 120 meter is wrong. Why? Again, show you first. Because where is your y? Your y, you decide is here, and therefore this y is 120, and it must be second. What else? This is second, ma. This is also second. This is 50, also second. So far, so good?
Yeah.
That is not the final answer. Come on, visually, you indicate to yourself what?
70.
The length of the time. Yeah, 70. Thank you very much. Obviously, Abigail, you're good visually. It's obvious to me. Once you decide to activate your ability to see things, you can see it very fast. It's just that you don't do that consistently. You basically shut off your mind. I'm not really sure. I sense that a lot during this doing of this question. You kind of shut off your mind. Shut off your mind. I have to, yo, Abigail, turn it on again, man. It turns out you can. Then you shut off again. Hey, yo, Abigail, turn it on again, man. Hey, and then you shut it off again, That happens a lot of times. Well, it's a bit of sayang because your mind turns out to be, I believe, quite good. That's what I feel, That's what right? You can correct me if I'm wrong.
Okay.
Abigail, there's one question. It's already 7:15.
That's
You gotta handle the second question. I can tell you, however, the second question seems to be easier than the first one. Way easier. The first one that you asked, definitely the harder one, and I'm happy that you did it. Totally fine. Okay, so I'll leave it to you, okay? Because we do want to study AMAT a bit early. Okay?
okay.
Now, to do that, again, do you have your textbook for AMAT?
Yes.
All right. Take a picture of the chapter that you haven't studied. That's the important thing. You haven't studied that. We're going to kind of review it to look at it together. Okay. Okay. Let's go to the AMAT Jamboard. Is that correct?
Yeah. Hold on.
Okay. Let's do that. I'm going to take a picture of anything. At this point, by the way, it's easier to use the video and the phone holder. And you do have the phone holder, right?
Yeah.
Next time, you put that. Reading the textbook is just way easier with the phone holder. Okay. The next time you set it up.
Okay.
I am not in AMAT.
I'm uploading it.
Yeah, I think you just gotta use. All right, I got something. Okay. Again, takes a long time for you to simply take a picture and show it to me. 5 minutes. With the video setup, you just have to show me, and that's the goal. Okay. Because we cannot predict which part do you need more explanation on. Please put on the video next time. Save you some time in tuition. You do need it, right? Now, all this fancy stuff, I guess, yeah, a lot of English, which which is not very useful. Yeah, I don't like your textbook very much. Absolutely not useful. Uh, Abigail, for today, I'll just summarize for you, right? Next time, one more time, show your video and your textbook, and then we can browse through it much better. Okay. For today, for the remaining 10 minutes, I'll show you something. Okay, I am sharing my screen already, so please look at it. Okay, so I don't know. I think your textbook is saying, hey, I give you y a power x. I set the a equals to 1. It'll be a horizontal line. Your textbook seems to be saying something like that. Am I making any sense so far? There you go. Am I making any sense, Abigail?
What?
Yeah, communication not very good, yeah. In the textbook kind of say y equals to a power x, a equals to 1. It looks like a horizontal line there. I show you a horizontal line in the picture. Does it make sense? Tell me right now.
I understand.
All right. Now, this is not a very interesting or exciting graph. This is probably not what they want you to understand. They want you to understand that there's this kind of graph. I'm going to shift the a into more than 1. Okay, just randomly. There you go. And then 2.1, just totally random, okay? Suddenly, the graph looks like this. I want you to focus on a very particular point here, this point. Please focus on that as I move my A. I make my A 3.9. Do you see what happened to that point?
Can you repeat that?
One more time. Here's 2.1. Do you understand what I mean by A equals to 2.1 here? Sorry. This is not the first time you see the small.
Or the point is like consistent.
I know. Even if I increase it, in fact, after a while, the graph doesn't seem to change much. There's a general shape of things, and that point kind of holds steady. You can see it very clearly. That is already one thing they want you to notice. Y equals to whatever. This is 3.1 power x. Is not so different from this. It's really not so different. Easier to show in decimals, right?
Yes.
Okay. The graph is also, frankly speaking, kind of simple looking. The table of the numbers in your, in your textbook seems like a very complicated set of numbers. And then you plot it, it becomes very easy. The shape is very easy. That's my message for students, okay?
Yes.
Now, I'm going to show you what happened when I make it less than 1. Okay, come on. Okay, almost, yeah, almost less than 1, almost 1. There's 1.1, it's 1, and then stop. There you go. Look at that.
The other side curves.
Right. I don't know, maybe call it a mirror image. I don't know, but the point is that one line, that one point stays, right? That one point stays, and then you get all this. Okay, you get all this. Now, I'm almost approaching 0. If I go to 0, just to confirm, the graph do disappear. Okay, paragraph. Graph do disappear. 0, 0, 0, 0, 0. There you go. The graph do disappear. Again.
Yeah.
What happens? They go to negative because negative is not in the syllabus, and the decimals kindly oblige. The decimals do not give you anything about negative, none whatsoever. It is not part of the syllabus, even though it's possible, but it is not. And the decimals oblige and say, I don't know what the graph you're talking about, something like that.
Okay.
So one more time, what matters to you seems to be, well, frankly speaking, 0 doesn't matter. Fair enough. 0 doesn't matter. 0, 0, 0, 0, 0, 0, 0, come on, 0. Minus doesn't matter. 0 doesn't matter. But less than 1, a fraction seems to matter. Okay? Fraction, yeah, less than 1. There you go. Less than 1. And then 1, and then more than 1. There you go. Okay?
Can.
Okay. So I believe this is what the chapter is trying to teach, at least one of them. One of them. You're going to flip your book, because I cannot see, and see whether they bother about any other type of graph. Maybe a log graph. I don't know. Give it a try. Quickly.
They do say log graph. Like,
They do say a log graph. Okay. Maybe you take a picture quickly and put it in, a bit troublesome, but just make sure what they are saying here.
Yeah.
Did you put anything for me?
yes.
Sorry, a bit slow. Okay. You put something else for me. Okay, great. Let's see. Oh, you put 2 things for me, right? Oh no, the sketch, the graph y e power x, you already understand now. Maybe something like that. I don't know. You understand that. Okay, good. Now, logarithm x. Okay, so let's see that. Let's see that in Desmos. It's just much better in Desmos. Okay, so I am going to leave that guy here, a power x, and I'm going to put a logarithm a, I guess. I can do that using Desmos. If I can do, you can do, by the way. Like Desmos is just a very, very good thing in general. What do? I press function. I press function and I find logarithm. Where is it? I have no idea. Logarithm. Ah, there you go. Logarithm. And there is no base. Wait a minute. How come there's no base? Ah, there it is. I'm looking for that. Wrong. Function logarithm base a. Here, you are free to set any base. Okay, let's put this as a. And then I'll put this as x. There you go. Okay, please see that this logarithm how to say it? This logarithm graph is what your textbook is showing lah. So, but I want to show you more. I want to show you that there's a very clear symmetry. Okay, I intentionally put that line so that you can see that, how come they're a bit symmetrical visually? Can you see that?
Yes.
There is no way for me to show it to you unless you see it yourself. But as expected, Abigail, your visual side of things are very good one. Easy to see things, right? And then I want you to focus on these 2 points. Look at that, okay? As I change the A, okay? As I change the A. Now I'm going to change the A by doing that. Look at that. Would you look at that? Would you look at that? Okay, it disappears, you know? There is a point of time where it will, it will do that. Okay, I'm going to just do that here. I cannot do that. 0.1. Okay, there you go. 0.1 is like that. A bit weird, yeah? A bit weird. Okay. 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Do you see that? 0.8, 0.9. A bit weird, yeah?
Yeah.
0.0, then it doesn't matter. And then suddenly you have 1, which doesn't matter at all. 1.1, like that. 1.2, and then I want to go 1.3, and maybe I just go to 2 immediately. One more time. At 2, this is a very normal shape. You should memorize these 2 shapes. You should. Okay, I'll point out a few key features. These are the key features. Visually, Abigail, if you remember this point, you kind of find it easy to remember this point, even though you may not know the reason. It's just that these 2 graphs are symmetrical, don't you think? It's just like that one. Correct or not?
Yes.
It's just that if this point stays, then this point stays asymmetrically nice, right? Okay. And then this line also, you will notice that the graph is approaching this line. Is an asymptote thingy. It approaches but never touch. Make sense?
Yes.
So if there is ever a symmetry, then the green graph, which is the logarithm, is also approaching this line without ever touching. Also an asymptote thing. Same thing, symmetrical kind of thing. Make sense?
Yeah.
Okay, and then therefore nothing eventful happens when you increase the A. Nothing much. The shape doesn't change much until suddenly there's a flip. So far, so good?
Yes.
Now, in the flip, I want you to understand it visually. There is no other way. Why bother? First thing first, look, the anchor point remains. Correct or not? The anchor point never changed though. The anchor point is still consistent. Correct?
Yes.
But because it flips, the asymptote of the red guy is in this one, right? It's now here. Because you flip what? Correct or not? You flip, then the asymptote moves there. The green guy, which is the logarithm, also flip up. Also the asymptote now like that. Okay, I mean, can you see it? It's not that difficult, something like that.
Yeah.
Okay, and then as you change the A, the graph will remain in this kind of setting lah. I don't have to say it. Let's try. 0.6, then 0.6, 0.6, about the same thing, right? The anchor point stays, the asymptote stays. 0.5, The anchor point stay, the asymptote stay. You see that? Okay.
Yeah.
Until 0.1, as weird as this graph look, look, the anchor point is still the same. Look, the anchor point is still there one. I'm going to clear it first. Just okay. They look so different. They're not. The anchor point is still like that. There. You see that? There. And then the asymptote is also still there, man. Also same thing, same feature. Nothing changes. Okay. Okay.
Can.
I summarized 50% of the chapter already for you. The rest, they're going to ask you to draw and everything. Of course, we should be discussing that, but time is up.
Okay.
Okay. For now, that's it. I will see you this Thursday, just the Thursday before the holiday start. Okay?
Okay.
All right. I'll see you this Thursday, but just checking, is there anything else you want to ask?
No.
Then, what is the promise of us studying before the class? What's my promise to you?
You score higher and like you understand topic more.
In the class lah. In the class. That's
Yeah.
my promise. I am responsible if that doesn't happen, so to speak. It's not your responsibility. You're just, following me right now. Fair. We are discussing this, and then you should expect, not I. You should expect, your class becomes better in some sense. Tell me in Thursday whether that happens or not. Okay?
Yeah.
All right. I'll see you on Thursday then. Right. Bye.
Bye.